Welcome, everybody, to 52 Living Ideas. Tonight, we'll be covering or continuing our series with Bucky Comprehensivity to understand and change the world. Tonight, we have my good friend, Curt McNamara back. He's gracious enough to lead a meetup each month on a different topic. And tonight we'll be covering one of Bucky's most well-known topics, which is interaction and precession. So, Curt, take it away.
Thanks, Joe. You're welcome, everybody. Glad to see you all. And does the screen look okay?
It does.
All right. So thanks for coming. And if you've been watching these for a little while, you know that recently we've been making them more interactive. And that seems like a good way to do a Bucky thing on interconnectivity and systems interaction. So we're going to continue with that. So if we're going to talk about systems interaction or interconnection or precession, which is the effect of one system on another, then we should start with talking about systems. So what is a system? And I'm going to ask you for your inputs and examples here in a minute. In Bucky's eyes, everything is a system. And you will find that this viewpoint is not universally agreed to in the world of the wider world of systems. They think that certain things aren't systems, and we won't really get into that too much, but hopefully by the time we get through explaining how Bucky viewed it, you'll understand his view, or at least you'll better understand his view that everything's a system. So this is one of his sort of famous equations, if you will. The U stands for universe, and it's capitalized because there's only one. And the universe consists of metaphysical things, and those are, well, he termed many of those generalized principles. Those are the things that were true everywhere and every when. And the metaphysical principles, their interaction, the way they work, allows certain physical things to occur. And that's the P. So the universe is the combination of the metaphysical and the physical. We sense or perceive the physical. We look at specific instances of things and we say, aha, I see that chair. When we see enough chairs, then we come up with generalized properties or principles of chairs. And then we start to work on the metaphysics of chairs. And when we have that in our head, we could build a new kind of chair without really referring to the old chair, because we know the properties, the underlying principles of chairs. For metaphysical systems, there are many things, and we're going to see one of the illustrations from Synergetics in a little while, where Bucky contemplated Plato's triad of beauty, truth, and symmetry, and said, really, those concepts, while they may be systemic in their own, right? Beauty may be entirely systemic on its own. Plato suggested that the three things together formed a system, and Bucky was like, well, can't be true, because a system has to have at least four components. The system has to sort of what we call divide space in two. It has to have an inside and an outside, right? And you can't do that with any less than 4 points. So once again, universe is metaphysical. That's really the way things are put together, the possibilities of how matter combines. I'll mention briefly, that's one of the reasons Bucky subtitled Synergetics the geometry of nature. He felt that this way of viewing the world geometrically was kind of nature's coordinate system. It was clear to him that what we call the Cartesian, right, the point and the line and the cube did not represent nature. They don't look like nature. Whereas things that are based on the simplest platonic solids, like the tetrahedra, especially these irregular tetrahedra that have ratios between each other that represent how nature looks like, he discovered that this sort of structure is really nature's coordinate system, and that there was only really a certain number of ways things could be built. And this is confusing when you first hear of it and think of it. One way to get your arms around it is many of you have had some chemistry, and you know that atoms, at least this simpler view of atoms, is composed of nuclei and then electrons. There's only certain sets of them, right? There's only certain amounts of elements naturally occurring, right about 92. And it turns out when they combine with each other, those elements, to form things like H2O, they do it in very specific ways. And so that's really the shape of nature. It comes from these fundamental properties, like the elementary particles that go below it. So an H2O molecule, to Bucky, is a system, for example, and many other things are as well. So once again, this is something that is not universally agreed to in the wider scientific world. But we're in the land of Bucky, and he had a very big mind, and you'll gain, I think, by enlarging your beliefs, at least permitting yourself to enlarge your beliefs, to think of this. A little bit more on metaphysical. So clearly the laws of science are the metaphysical properties. I mean, they describe how things come together, like I just talked about the H2O molecule, right? And then Amy Edmondson's book, A Fuller Explanation, goes into a nice description of how a thought is actually systemic. So if we kind of summarize what she was saying, and she's paraphrasing Bucky, or in some cases she's quoting him with quotes in there, that when you think of a thing, you call it spontaneous preoccupation, and as you do so, your mind is sort of wandering around, but eventually you focus on a thing, and when you do, he says, you kind of dismiss things that are wider and outside of it. And you know how this works. You come into a room and you observe a chair, and as you do so, you're probably aware there's a clock on the wall, but you're not really focused on the clock. The clock is not part of your perception of the chair. So he goes on to say then that thinking in this fashion, which is what we do, it isolates events. And then when we put a little more effort into it, we have this understanding, right? And this is how we start to make these connections that become generalized principles. Understanding, he called it, was structure, the interrelationships between events. And finally, a thought then is a relevant set or a considerable set of things that would represent a system, by which he means something with at least 4 points that separates the universe into all the stuff inside of it, all the stuff outside of it, and then the boundary. So I know these are kind of big ideas. We're starting with big ideas, and we'll keep going, and maybe by making more visual things, it'll help. I like this sculpture. I took a picture, I think, at one of CJ's events, the Synergeticists Collaborative, or Synergetists of the Northeast Corridor. What I like about it is that you see that even with a minimal system, which is what that is, the tetrahedron, it can be subdivided into finer and finer things. And this is really, what happens when we perceive a system and isolate it, if you will, from the universe. We have the outside, everything, that's not a system. We have the boundary, the connections that define the system. And then these lines that we see between the corners, he emphasized, were relations, and were really the core way that universe happens. The universe is not physical things in structure. The universe is energy, events, and forces, verbs, right? I seem to be a verb. And so that's what these edges are. So once again, a system is composed of a set of relations, and the minimum would be at least 4 relations. Actually, 6 relations, both between 4 nodes, I should say. And the relations represent something active, some sort of an action or a potential, force or a field, a verb, potential, that sort of thing. The corners or the nodes are where those relations come together. And it's important to emphasize that they can come together and then disassociate very quickly in nanoseconds or faster, right? In the case of atomic stuff. So we tend to view systems as these static things that stay the same way they are. And this was not Bucky's view of the universe. The universe, he thought, was just continually coming into and going out of existence. So these relations, which are the edges, come together at the nodes. There's this interaction at the nodes between the relations. And that happens long enough to define a system, which we perceive as something distinct from universe. Now, interestingly enough, and I didn't put this slide in, but Bucky emphasized that if there is a quote unquote a law of physics, which says that for every action, there's an equal and opposite reaction. And he was quite clear that that couldn't happen, because that would essentially mean that the energy would be annihilated. And so then the actuality is that for every action and reaction, there's a little extra. And that little extra energy is what he called precession. And one way he described that in terms of this sort of a model is that every system has leaky corners. So the nodes are all connected to something outside, and they all have a little energy, material, or information either coming in or going out. Nothing is perfectly balanced. There really are no closed systems in the Bucky universe. So this is kind of the basics on systems. And then I want to talk for a minute about these edges or the relations. Well, sometimes we view those as flows, so you could see those as substances like water or energy. Or we might view those as information, as when we're perceiving something, or what I might call sensing it. It could be an outgoing flow, like when we're talking about something or touching something. We often represent these as arrows. If we're drawing a diagram of the relations between things, we often draw an arrowhead on it. And so then that lets us think about the direction of the flow and whether, in fact, that flow sometimes comes back the other way. In some cases, that means you draw a second relation. In some cases, that relation or flow isn't instantaneous. It might have a delay, or what we call a gating or valving function. And that would be similar to the ideas of Donella Meadows. So Donella wrote a number of excellent things about systems, and one was 12 places to intervene in a system. And those can all be viewed in this way, right? As a way to sort of change or modulate a relation or add a new one or take away another one. So there's many relations possible between the edges of a system. And let's see what my next one is. Well, good. It's sort of a blank slide for the moment. So what do you think when you think of relations or active forces or fields or flows? What sort of thing comes to your mind? I'm curious for your ideas. And yeah, so just put something in the chat, or I think the method here is put an exclamation if you want to talk, and we'll just spend a couple of minutes talking about, how a system might be composed of relations and what a relation might be that would be interesting. I think you can find systems by locating a relation. If you find a connection, especially a surprising one, if you find something that's like, oh, this is influencing this over here, then you've detected a significant part of a system. But you really won't understand what that thing means, right, until you sketch out the stuff that really produces or supports that, if you will. So hopefully this isn't too fast and confusing. And so it's also a time you can ask a question of clarification, or like in the case of Jeannie, say something that actually is much better formed than I've told you. So feel free to comment or, put something in the chat about relations if you would.
So folks, go ahead and feel free to enter something into the chat or type exclamation point in chat to speak or to ask a clarification question or to offer any comments. Can you give an example of a leaky corner for us, Curt?
Sure. Right now, you're kind of experiencing a leaky corner of Curt, right? I have a lot of information about Bucky, and so it's sort of leaking out, right, via my PowerPoint and my words. It's kind of an odd combination of words that Bucky used, but it's interesting. I think it's odd enough that we can remember it. So we'll get a little later into how people are polyhedral systems. And this is easy to understand. So I've only seen one thing in the chat, so I'm talking you guys until you can come in and say more. But people are obviously physically polyhedral, right? You could have a 3D scanner and it would go and it would come up with, something that would define the exterior of my physical body. We're also metaphysically polyhedral. And what that means is I take in certain things, so food and water and air, and then I excrete other things. So I've got these physical systems going on. But then metaphysically, I'm taking in information. I'm reading about Bucky. I'm listening to other people. I'm engaging in discussion. And then I talk about it, right? And so then, so one of the leaky things is things are leaking in. And actually I'm seeking stuff, right, to absorb it at one of my nodes. So that's one example. Maybe it's not a great one. What's another one? Companies have physical boundaries, or organizations have physical boundaries, and they also have metaphysical boundaries. But the metaphysical boundaries are leaky. What do I mean by that? If you're the spouse of somebody who works in an organization, you probably know more than maybe you ought to, right, about what's going on. The organization may want only the employees to know, but it's always true that I think the partners or spouses know stuff about it. It just leaks out, if you will. It's not really intentional, but it's really part of what we're going to talk about in a minute, systems interconnection. Okay.
So we have a comment from Maurice, and then we have Bill as well, and then we have Jeannie with her hand up. So Maurice has undulating spinal movement during a movement practice like yoga. So that is his comment. Do you wish to unmute, Maurice, and share anything more about that?
Yeah, I'm not sure what Curt was asking. What I heard was, I think you were asking an example of systems movement.
Yeah.
And
that's good.
Yeah.
Okay. Yeah, and the spine is obviously a super complex system, right, with many subsystems. And I think you got an excellent example, Maurice, of how the little, what do I call the vertebra are actually, you're saying undulating, right?
Yeah.
So it's a complex movement, right?
Yes, it's. I mean, the design of the spine is snake-like, so it's basically designed to move in an ideal way, to move and to undulate, and that actually comes natural in a lot of yoga practice, a lot of yoga poses, and if there are moments where when you really get into it, you're letting your body flow, or you feel yourself moving flows through your body. That's what my experience is like.
Great. Thank you. I appreciate it.
So next up, we have Bill, then followed by Jeannie.
Thanks. So when I think of nodes connected by relations in human systems, for example, each node could be a person, and each relation could be the relations between the people. And in terms of like energy flow, Like what would be the analog to that? Well, it would be expectations. Because usually human interactions are based on expectations where each person decides how to behave towards the other person based on their expectations about what the consequences are going to be of behaving this way or that way. And expectations can be structured contractually, all sorts of different contracts, not just economic contracts, social contracts, political contracts, international contracts. And the function of the contract is to structure the expectations so that the behavior is mutually beneficial. But expectations can also be formed in non-contracted relationships where people are each one's maximizing unilaterally, possibly at others' expense through opportunism or what have you. But again, expectations come into play. So that's what I tend to think of, partly because I have a PhD in political economy and I'm trained to think that way, but also because in these meetups around Bucky's work, I hear a lot of people making these analogies between Bucky's literal architectural engineering models and human systems. And I think sometimes those analogies can be helpful, but sometimes they can get carried too far where the metaphor really doesn't apply. So I'm always applying a critical lens when I hear people making those analogies, because humans don't interact like atoms or like steel girders in a building, that an architect has designed or something, for a number of different reasons. But I'll leave it there for now and maybe circle back later. So thanks, and I'll pass.
Okay, well, thanks,
So really
Bill.
quickly, can
Go ahead.
just get a clarification? So, Bill, were you like basically saying written contracts and unwritten contracts, essentially, like unwritten rules of interactions, just to make sure I'm getting exactly what you're saying clear?
I would lump the written and unwritten contracts both into the area of mutually beneficial interactions between two or more individuals, where each one's contribution bestows a benefit on the other, and reciprocally, in such that they're better off in the cooperative relation. And both of those, both explicit and implicit contracts, are mutually beneficial. But then there's other kinds of interaction that are conflictual, in the sense that each is imposing costs on the other, unilaterally imposing costs on the other against their will. Not just military conflicts, it can happen in labor management disputes or disputes between friends, whatever. And that is mutually detrimental, but it still involves expectations, in which the relation between each actor's behavior is based on their expectations of the consequences of their behavior, including how the other will respond, etc. So yeah, that's how I'd parse that out. So I'll stop there.
Okay, well, yeah, I was going to respond if that's all right.
Please.
Okay, thanks. Yeah, so excellent example, Bill, because thinking of ourselves as a polyhedral system, right? And so expectations are kind of, I would say, based on behavior, right? We expect another person to behave a certain way, talk a certain way, act in a certain way, whatever you might want to call it. And so one of the ways to really sense how much we're subject systems interconnection interaction is think about the way we talk when we go into work, right? When we go into work, there's certain things, that we talk about and stuff that we don't, right? And when we go home or go with the buddies at the bar, once again, there's very different things. And so we're the same system, right? But in each case, we sort of expose different things. We have different behaviors. And so then the interaction of systems kind of depends, or in a way, it kind of determines, right, how each individual system, winds up responding and behaving. So that was great. Thank you.
Can I add briefly onto this?
Sure.
Okay. So actually, I'll save it for later, since I've been.
Why don't we come? Yeah, why don't we get to everybody else, and then we can come back to this, because I think that this is actually a very interesting point. So with that, and actually now we have a number of individuals with their hands up. So we'll go to Jeannie first, and then Ginny, and then followed by Wawan, I believe.
Well, I really enjoyed what you said about the action and reaction requiring a little bit of extra energy. And I think the same is true when you have things, you know, trying to initiate something. Because if you have two people and they each give 50-50, the thing will not happen. Everybody's got to give 51%, or at least one person has to give a little bit more than 50%. There seems to be an inertia that happens before so you need that extra energy somehow to get things started. And I don't know if that exactly applies, but it seems like a sort of general principle that you need a little extra energy here and there.
That's great. Thank you. I love it.
So next up, we have Ginny.
Sorry for not muting more quickly. I just want to agree with what Bill said earlier. I concur with all he said. That's all. That's all.
Thank you. And Wawan?
Yeah, actually, I didn't very well about system, but you was telling me you were telling me very clearly about force, role, and flux, and this is related to chemistry, and yeah, I just giving a comment like relation can explain by concepts like this fiction in both and now it's like a kite, yeah, and yeah, I I was astonishing about your explanation, and this is a new experience for me to see about this topic today.
Thank you. Yeah, so I didn't catch everything. I have bad hearing. So many of the things I'm talking about are really in Buckminster Fuller's Synergetics. And I'll put a note in the chat, or somebody, maybe Joe, will do this for me. But Synergetics is now online, both volumes together, at R.W. Gray's website. Maybe just Google R.W. Gray Synergetics, you'll get it, or Jeannie knows how to get it. And so, you know, his words are hard many times for us to comprehend directly. And so I'm giving you another point of view about this, and I don't completely understand it. I mean, I've been working on this stuff for a while, and some of these things are very deep and challenging, but I appreciate your comments. And I also think that Amy Edmondson's book, which I had a quote in from earlier, is another really, well, it's a much easier way to get into the synergetics material than actually reading synergetics. So it's called The Fuller Explanation, and one of us can put that in the chat as well. So thank you.
So Richard, do you want to unmute and talk about your comment, or just we can just leave it as is? And Bill, did you want to finish your comment?
I'll just say it in the briefest possible way. When engineers and architects design buildings, there are certain stability conditions that need to be met for the building to stand up. And it's the same in human relationships. There's certain stability conditions that need to be met for a contractual, mutually beneficial relationship between two people to continue to be mutually beneficial for both. And so that's kind of, there's some kind of analogy there. Like what are the stability conditions for things to continue, for the building to stand up, or the mutually beneficial relationship to continue? Like how do you systematize that methodically. What are those stability conditions, and how do you ensure that those stability conditions continue to be met as the relationship between the two nodes is buffeted, like a bridge buffeted by winds, or a contractual relationship buffeted by changes in the costs and benefits of compliance, et cetera, et cetera. So that's kind of the underlying, seems to me, basis of looking at of how to transform synergetics into human relationships is stability conditions. Because I think that's what motivated Bucky a lot, was like this precession, like the perpendicularity of something holding something else up. That meets the stability condition that angles at other angles don't meet. That perpendicularity meets the stability condition. So yeah, I think that's where I would go with it if I was looking for analogies.
Yeah, so
Yeah.
it is probably time to move on. Excuse me, but to your point, so far, I'm talking minimal systems. And a lot of you guys are so smart and so comprehensive that you are jumping to larger systems right away, right? And that's great. And so and especially Bill's stuff, I mean, we're talking now interacting systems, right? Like I have relationships with work. There's expectations that I'll quote unquote show up, that I'll produce things of a given quality and quantity, right? There's expectations, right, that I'll get valid and consistent inputs and et cetera. And none of those are single lines. Those are a complex of lines, right? And there has been work in this area. Many organizations don't deal with the complexity. They just simply say we're hierarchical. It's just one way. We're just going to tell you what to do. Don't talk back to us. But now there are more advanced organizations that are using teamwork, and they're incorporating this fact that you have actually a complex of people. And if you can deal with it, you get a much more out of the people that are in your company. So, and this is almost a whole different lecture that we could do sometime. But I agree, it's a very powerful thing. So I think I'll move on unless Joseph thinks to do anything else here.
Yep. I think we ought to move on as well. So
okay, cool. So I mentioned this in the past, or a few minutes ago, which is a figure from Synergetics. And so this is Bucky saying, well, so Plato said there was a triad of beauty, truth, and symmetry, but it can't be a system unless you add a fourth node. What's the fourth node? The observer, or the self. And that makes intuitive sense. I mean, we see it and we're like, well, yeah. But now we also see that since he's put it in a graphical representation, the truth relates to beauty and symmetry simultaneously, right? And so these are not independent things. The truth and symmetry and beauty, right, to the extent that Plato was correct, and we tend to believe Plato's correct, right, they're interdependent, and once again, very dependent upon the observer. How is this still not really a minimal system? Well, what's the observer observing, right? So there has to be another system, right, that the observer is observing, and then from that coming up with his ideas or her ideas on beauty, truth, and symmetry. So some things that's easy to see are systems. And I love the bicycle. And one of the reasons I like these pictures are you can see the complexity of the bicycle system. We may not think of it as much of a complex system, but it's very complex. It's composed of many subsystems. Each subsystem has multiple manufacturers. Luckily for us, there's a bunch of standardization in bicycles such that you can buy wheels from all kinds of vendors and they'll fit, and gears and everything else, right? And so then we're surrounded by systems. And then once again, how are they used? We might think, oh, I'm going to go out for a ride today, right? Like I'm going to ride down to the valley, which I do here. But then you think of how they're used in other countries, and you're like, oh my gosh, it's such a big deal. So I mentioned before that people are polyhedral systems, and this is some student work when I taught at the Minneapolis College of Art and Design. And I said, envision yourself as a polyhedra. What are the inputs and outputs? And this was all very tentative exploratory work. It was a short course. They had very little time to do it, but it just shows you, right, that you can think of, as he puts it here, a physiological output that might, and part of it be consciousness, a spiritual output, some connections to family, interfacing with other beings, et cetera, et cetera. So it's worthwhile, I think, to view ourselves this way and make a simple sketch. because you'll discover a lot of complexity in your life, right? And you might say, whoa, wait a minute, there's so many things here, right? And so anyway, just a recommendation. And so then this shows you, I think, intuitively obvious that yes, we are metaphysical systems. What's beneath this? Well, for us to have any given sort of behavior, output, or belief, let's say the spiritual one, it's not like a single point, all right? It's like a connection of multiple things within it. And I won't even try and go into it, but you all understand that there's a lot of complexity that results in our relationship to nature, whether we call it spiritual or scientific or whatever, right? It's a whole bunch of things that result in that set of behaviors. And then in terms of relations, on the right side is illustrations for a paper I did, well, not quite 20 years ago, where I tried to really get down into, in this case, a furnace, and how you would sort of, if you had a flame, how it could be produced. And I was trying to follow along with Bucky's logic of a system is two interacting events. And we're not going to get into that tonight, but that's very interesting. If you look at it, he says that a tetrahedron is composed of two triangles, and each triangle is an event. It's that action, reaction, resultant, or precession. And I said, oh, well, I can model, something in a furnace, and it's very complex. I chose the wrong level, I'm pretty sure. I've left the paper up on a website because like someday somebody will go and look at it and say, okay, I can see where this guy went wrong, right? And they'll do a better job at it. On the left is a system dynamics model, what's called stock and flow diagrams, and it's used by many people in systems thinking. Well, guess what? This is all in terms of relations and flows. And I think if they wanted to figure out if they had really a good systems view, they'd put this in 3D. Right now, this is in 2D, and it's got sort of these abstract concepts in it. But I think you could make a 3D model, right? Grab your zone tool, put it together, and you may discover missing connections, or you might discover what we call overdetermined connections, which would let you figure out better stuff about it. And then now know all this stuff about mycorrhizal DNA or mycorrhizal fungi, and how they interact with the tree roots, and they have a symbiotic interconnected system between the two of them, where the one feeds the other and the other transports materials, and by doing so they enrich the soil and they enable both species to live, and the soil food web the same. So we're in a web of relations, and it's much more a world of relations than it is of things. Now, I did this is called a concept map, and a concept map is something where every time you draw a line, you have to say what that line means. And I really like that practice. I really recommend it, that every time you draw a little diagram of something and you draw a line between them, you say, aha, what does that line mean? And so in this program, CMap Tools, every time I draw a line, it pops up a question mark and says, well, what does it mean? And in this case, I was thinking about food and regenerative systems. And I said, well, what's the core thing is a household. And then they have a couple of ways they could buy things. They could go to the supermarket and do all the standard stuff, or they could go to a farmer's market or go to a thing called a community supported agriculture, or even a farm itself. So they have to make choices. So they have these interconnected systems, but they're subject to other forces, right? Like family members, like advertising, like costs, like convenience. And so then if you're going to try and explore, sort of transitioning people to a different way of getting food, you have to make this kind of a model. And guess what? It's the relations that really determine what's going to work and what's not. You may have to put in a new relation or modulate a relation, or, minimize another one. So, okay, a lot of stuff on relations. And so this is where I usually stop and I say, okay, tell me about a significant relation. And we've already done this to some extent, so I don't think we'll pause on this one. But yeah, I will pause long enough for you to think about it, because like, even as I was suggesting in Bill's example of the expectations or even contracts, right? there is something going one way, right, between one party and something coming back the other way, it's hardly ever just, oh, I'll give you money and you'll give me a thing, right? There's that other expectation part, like, oh, the thing you give me will have a certain quality, won't it? And in business, there's a lot of stuff that goes into it. It turns out that beyond this, just the simple transactional exchange, there's another one where a party says, well, I want to get a certain amount of this over time, so I will guarantee to buy it, but only if it looks like this and acts like this and lasts this long, right? So this gets complicated. But once again, emphasizing that systems are relational, they're energetic, they're continually modifying, especially with systems interconnection, continually modifying that web of connections between them. Oh my gosh, those parts didn't work quite right? Or, oh my gosh, this work you turned in doesn't really fit what I need, right? Continually being modified. Okay, where'd the cursor go? So this all gets connected into systems change in Bucky land. And so last month we talked a little bit about trim tab, and just a reminder that, the classic trim tab example from Bucky land is that the trim tab is a little rudder on a rudder. So the big ocean liner has a rudder as big as my house, but the trim tab might only be a foot wide. So I can move the trim tab, and when I move the trim tab, I produce a lower pressure area, right? Because the water is flowing against one edge and it's being compressed, and therefore there's lower pressure over here. And what that means is the big rudder moves. So Bucky loved the idea of the metaphor of a trim tab as a way for systems change. But the second one, which is what we're talking about tonight,
I'm assuming that's Curt. Yeah, I'm assuming that's Curt.
Yeah, I think it is.
So we will wait one more minute to see if he comes back. If not, he may have to log out and come back.
that's a classic.
So there we go. Okay, so Curt, you actually went out for about, I don't know, maybe 30 seconds, maybe a little bit more than that. So if you could just repeat what you just said, so that everybody's on the same page.
Okay. Yeah, I know what it is, and I should have checked it before I started. I apologize. No problem. But we'll just hope. So I was saying that often people get attracted to Bucky because of ideas about systems change. And one of those is trim tab, and I use the example, of the little rudder on the rudder producing lower pressure. So can produce the direction of a big system, and that was a thing Bucky often loved. And in Precession, it's an idea of systems coupling, and his classic example was the pollinator and the flower. So when the pollinator flies in, it's not intending to pollinate, it's intending to get pollen or nectar to feed itself, but it picks up the pollen sort of at right angles, and then when it gets to the next flower, it winds up pollinating the next flower, and everybody wins. And so this is Bucky's example of precession as something that happens unintentionally at right angles to the intended action. The intended action being, I'm going to get some pollen or nectar, right? And picking up the pollen it's not accidental, but it's not intentional. And then I was just about to say that that's really an example of systems coupling or exchange. And we've already talked about that a little bit more on that in a minute. And then future talk, we'll go into another thing Bucky said is don't fight the existing system, create a new model, which often is a network. And then finally, design is often a way to accomplish systems change. And it could involve any of these, but also other things. So this is an illustration, once again, from Synergetics. And in it, he's showing that there are 3 ways for systems to be interconnected. At the lower right is a single relation. And once you remember, it's a one-way, it's a single connection, one way. And he likened this to molecules of gas. They're free to move wherever they want. They're loosely associated, but they don't, have anything really in them. You might even, yeah. And then in B, you've got these two systems that are related on 2 points, right, or 2 edges. And what that means is they can move like this. And now you have something that looks more like a liquid or a metal in some cases, right? There's flexibility because these molecules are more closely affiliated, but they're not bonded together really, right? You can take them apart, right? And then finally, when you have at least 3 points of connection, you form a new system. So this is, a classic Bucky explanation of the systems coupling. So metaphorically, we know that this lower right single point of connection is what would represent an extractive operation. If we're simply pulling something out of the ground, or if we're mining something and we put nothing back, we're depleting the systems, right? We've depleted many, many natural systems, and we can just know this because this is a single point. There's no closed loop, there's no circularity, right? And we could, with all these systems, come up with a way to return things to the earth, but this would require at least another connection, maybe more than one. And so then we kind of know then that any single connection, it could be like the one-way hierarchical command, but it doesn't represent a living system that's regenerative, right? In the hierarchical command, if you never get information back, eventually it's going to break apart. We just know that happens, right? So anyway, if we then know that if we want to have any sort of reciprocal system that benefits everything, there has to be some sort of exchange, more than 1 point of coupling, I guess is what I'll say. Okay. And then this relates a little bit to our previous thing about how we as individuals change in response to external systems. This is an illustration from Darwin's long paper on the movement and habits of climbing plants. And so if you've ever seen an illustration or a video of a vining plant like a bean or anything else that's starting to grow, it's looking for a support. And it typically does some sort of pattern over time. And then by whatever method, in some cases it senses olfactorily, or some cases it's shadow, or even stuff they don't really know about, it then bumps into something that it could actually climb on. And then it starts a second kind of an operation of wrapping itself around it, which you can see on the right side. And so there's now a book called Plant to Sapiens, where the author says, it's fairly clear that there's some sort of consciousness in plants because they're doing this and they're responding to the external system. Well, it turns out in many cases, this external system is also changing over time as well. And so this is once again one of these systems interconnection thing where both sides of systems are changing to produce this final result, if you will, from both these things. So we're going to talk about precession. We should talk a little bit about another classic example, which is orbiting. So we tend to think of orbiting as the moon orbiting the Earth, or the Earth orbiting the sun. So we have one larger body and the other one smaller one that's in this sort of a stable relationship. It's a balance of forces, isn't it? It's got to be a balance of forces. If the force of attraction was greater, then the moon would slam into the Earth, but it doesn't. If the force of attraction was less, then the moon might fly off somewhere else, right? But it's wound up in a spot via the magic of science and generalized principles where it basically balances. The force of falling in and the force of flying away are quote unquote balanced to form this orbit. And the orbit is this extra energy, this precessional thing, right? It's the action reaction balance of this orbit. And so then this is one of the 6 classic motions that Bucky defined. And we're not going to go on the others, but once again, this could be a very interesting topic for some time to talk about these other things, like the fact that since we're all systems, all of us, right, metaphysical and physical systems, all of us are continually spinning, right? And we don't perceive it, but we are. So then I, for a while ago, drew some simple diagrams just to help this with myself. So here are two systems that are interconnected and they're in an orbit. And then here's another one. And the interesting thing was, as I worked on this, I realized that, let's just say that, you know, in a relationship, you have a partner. Well, you may think that you're orbiting your partner, but guess what? Your partner's orbiting you, right? And so then there's actually a fairly complex dance as you go through time and space, right? Of these kind of things. And Bucky actually has a nice illustration of this in Synergetics. I didn't put it in, but it's a nice illustration. The other thing that happens is that you may be orbiting an organization like work, but yet you have to spend time also orbiting your partner, or guess what? It won't be a stable relationship. And somebody pointed out that Hofstadter, in one of his books, explained this as essentially it's like a shared electron. So when you look at how how atoms get bound together in molecules, what's happening, at least metaphorically, is that this electron spends some time around the big atom, let's say, like work, and then some time around the smaller one, which might be the partner. And so then you have this sort of complex thing that you're doing. So what is the thing to remember? These things are all precessional. They're all a combination of this falling in, right? If I fall in too far to work, boy, oh boy, you know, that's not a good thing. If I don't stay, you know, if I don't have the right contracts and expectations, it'll fly away. And the same thing with my partner. And we're all balancing this every day for a whole bunch of stuff. It's, you know, amazing the stuff that we're doing. Okay, and then this is kind of similar to what we've talked about in the past, but this is an illustration of how when an action and reaction come together, they don't cancel out. There's something else. And guess what? We're going to pause here in a moment and talk about an example of this excess energy. Sometimes Bucky referred to it as unintended effects, side effects, effects at right angles. But I'm going to prompt us in a minute to talk about some example of this unexpected thing, this excess energy that was surprising to us. I looked up synchronicity at one point just to see if that related to it. It's sort of related, but not exactly. And then just once again, this is that very simple illustration that in a node, you've got forces coming together, but it's always more than two. It's got to be at least three, right? You might have two inputs and one output, or two outputs and one input. And guess what? There's always a little extra, right? That's the precession, that little extra that we're talking about today. And so then this is just a slightly different view of it, right? Showing that, you know, in some cases that little extra might be, I need this thing, right? I need this input information. I need this food. I need this whatever. And in other cases, well, I've got extra energy about Bucky, so I'm going to talk about him tonight, right? So this is the sort of thing. So I spend a lot of time on this, and I'm hoping that it sort of makes sense that we can kind of view this little extra thing. And then, of course, there's his classic illustration of precession, which is when the guy jumps from one boat to the next. Well, guess what? The boats each go away from each other in surprising ways, right? And so this is that, and he shows this as two vector diagrams. And so this is another way to view how this would work. But on the top, of course, you have action, reaction, and resultant sort of going one way, and the bottom, action, reaction, and resultant going the other way. And so then the initial conditions, if you will, which is the position of the boats, determines kind of what the arrows look like. And same thing with us when we jump into a new thing, right? The conditions of the two things determine how it's going to go. This is a lot of words from Bucky about precession, and basically it's saying that everything in the universe is precessing. Everything is, you know, coupled to other systems. It's just the law of the land, if you will. Precession is regenerative, and that is why you have the wave. A person could spend a long time on this, right? That the wave is really the result of precession. Yeah, the wave is a 90 degrees begets another 90 degrees begets another 90 degrees until you have a whole series of them, et cetera, et cetera. So orbiting of the planets and the solar system's precessional. So a lot of good stuff here. So I always recommend going to look at Synergetics. And then once again, same idea. In this case, I'm just saying, well, you can start to think about your ability and desire. Maybe part of that is, oh, I need to learn more. Or in other cases, it's like, oh, I can create something now and I have an output, right? And then just yet one more, right? So our universe is composed of systems. Systems are made up of events. Events are action-reaction pair, but there's always something extra. And that's how systems couple together. And that's how universe works. So that's kind of in a nutshell, this is what we're talking about tonight. And so then here's a bumblebee, and that bumblebee is picking up pollen. That's just what's happening. And I have I think one more, whoops, which I put a tetrahedron on top of one once. And I said, oh, how would you represent all the behaviors of a bumblebee tetrahedrally? And so this is probably going a bit far, but I think it's interesting to sort of start to use these ideas, because we do know that at this level, it's certainly far more complex than a tetrahedron, but it is a polyhedral, and it is dependent on a whole bunch of things that are happening. And let's see. Well, this is me making a concept map of precession, just trying to unpack it. And I also recommend this sort of an approach if this really is something that you really want to spend time on. So, oops, and then there's a bunch of references. Well, there you go. There's a lot of stuff just so we could have a good discussion on precession now. So I'm gonna mute, look at the chat, and Joseph will coordinate it.
Okay. So folks, go ahead, type exclamation point in the chat, or raise your hand in Zoom to make any comments that you have about the presentation itself. And if you have anything to offer, or if you have any questions actually for Curt, that'd be great. So looks like we have a couple of people already that are with the exclamation point in the chat. So first up, I believe, is Ebony.
Hi, Curt. First of all, I wanted to say thank you for a great presentation. It was really enlightening. I do have a question, and this might sound out of left field, so I apologize in advance. When we're talking about precession, and you showed that last picture of the bee pollinating, and you were saying earlier that just happens like I almost think it's like an unintended consequence in a good way. That the bee's just doing what the bee's doing. He's thinking about pollination, like he's just trying to do what he does. And then we get the consequences, like we get the good consequences, right? Is that accurate as to what precession is? It's like, you're doing what you're doing, and then, there's these things that happen because of that.
Yeah, I think you have it right on. And Bucky had another view of this, which is he felt that he was like a bee, and he was trying to pollinate ideas in other people's heads, like students. And if he did it successfully, he'd wind up getting paid enough to survive. And if he didn't survive, wasn't getting enough to survive, then he wasn't doing a good enough job, right, of this processional pollinating, and he had to do a better job. So what's happened over all the evolution of all the systems in the universe is that ones that have this processional effect have been more successful. There's other ways to view it, but that's really what's happened, right? I mean, just think of a pollinator that doesn't pick up the pollen, right? It's going to be disfavored, I'll just say, by the flowers. And there's whole books on how flowers have optimized themselves to I just read about a flower that when it senses the pollinator coming in, it closes off the place to get nectar, forcing the pollinator to bump against the pollen, right? So just a huge variety of stuff. So the ones that have figured this out are more successful, which is why we see them all over. And now we know about it as people. And to some extent, maybe we can design for precession, or at least understand this idea, right, of doing something better, more than just oh, I'm going to get this thing and I'm going to give you $1 for it, kind of a thing. So yes, you really have it, Ebonique.
Thank you.
Thank you. Then we, Ebony, do you have any follow-up or?
No, I'm good. Thank you.
Okay, so next we will turn to Bill.
Great, thanks. So I've been listening in the Bucky meetups for clarity on what precession meant to Bucky, and now I have it. Thanks, Curt. So this notion of unintended consequences. Well, actually, what precession means in physical, in the world of physics and architecture, that's one thing. But in the world of human relationships, it seems to mean unintended consequences of intentional behavior. So in social science and political economy, first of all, some people define social science as literally the study of the unintended consequences of intentional behavior. So second point, when an intentional action has unintended negative consequences, there's two possible outcomes to that. One is that the sufferer of the negative consequences continues to have to suffer them. The other is that the causer of the negative unintended consequences has to for some reason winds up changing their behavior or otherwise paying the costs of the unintended consequences of their behavior. So which outcome it is can be determined either by law. In some cases, law distributes the obligation either to the sufferer to keep on suffering or to the causer to curtail or otherwise pay the price. Law is one way. Markets are another way, like automobile recall, for example. When the automobile company made a mistake in production and has to recall 500,000 cars, it's doing that to avoid a loss of reputation that would lose it business in the future. So it winds up having to pay the cost of its own mistake. A third way that this dilemma gets resolved is through politics. A fourth way is through social, like dynamics, people canceling each other socially and et cetera, et cetera. So yeah, I just wanted to put those building blocks out there for those who are interested in pursuing precession in human relationships. Negative unintended consequences are pervasive, and you could tell a long story of human history in terms of the arrangements that came into being to reduce negative consequences, negative unintended consequences, et cetera. So that's it. Thanks for listening.
Yeah. So, we like to talk about this happy regenerative stuff, don't we? We do, right? And yet the world is full of somebody put in viruses and parasitism and all this kind of stuff, right? And I think, as individuals, as human individuals, we make choices too, right? And so it's like, you know what? I'm not going to go with that dude anymore. That was his bad stuff. I'm not going to work for that company anymore. So there's that whole dynamic as well. But you did an excellent job of saying that in a fixed relationship where you may not be able to kind of get out of it, then you need this higher level system, right? Some sort of higher level system, which, you got to have. You got to have this social contract, the politics, the law, whatever it is, right? Because this is going to happen, that we're not all happy bees, right? Or consistent with our behavior. So it's great. Thank you.
Yeah, I think that is actually maybe something we can come back to. I think that there are a couple practical examples of it maybe we can go to. But let's go to Jeannie first.
Well, in thinking about that, I think there's an iterative process where you try a little bit and experiment around the edges, then you test and see if it worked. You test what your consequences are. And there's ways to, measure and figure out what you're doing as you go, rather than, and I think, one of the big problems is scale. So when your scale is so large, then every time you make a tiny experiment, you're going to have, things that you couldn't handle before. And so I think part of it is to keep things on a small scale and to keep testing and to keep iterating, not to force things too fast in one direction. That's just my suggestion.
Yeah, that's great. So some of that I think is related to tinkering or prototyping. And I think this is a thing that's becoming more and more prevalent, right? With hacker spaces, maker spaces, people encouraged to do their own thing. There are, how many YouTube videos on everything now. Yeah, I really think that's important. And that's a whole nother thing. It's another book almost, Jeannie.
Good. Thank you, Jeannie. Next up, we have Luke.
Hey guys, can you hear me? Good.
Sure. Yes.
So Curt, the talk on Precession was really kind of enlightening for me, the way you said it. And I've heard you say it before with the bees, but I think it just went into deeper depth there. So where my mind went, interestingly, because once you gave me a hook to hang on, I'm like, well, I've heard of things that sound like this definition. And the first thing I thought of was externalities in economics. And it seems to kind of hit it right on. But there can be negative externalities as well as positive. Am I on the right track?
Yeah, there certainly are. And, just to the previous comment, we really haven't explored that. But clearly, there's relationships where one preys upon the other, right? And, some would claim that you can't view it quite that simply. Like people viewed the wolves as a bad thing, right? Because the wolves would take down elk and things that they would hunt. And they actually pretty much, they extirpated, or whatever the fancy word is, got all the wolves out of Yellowstone. And then Yellowstone sort of became kind of a mess, right? Because the elk or whatever it was overran it and had all these other things. And so they finally reintroduced the wolves, which previously had seen as a bad thing. And they put the elk population in check. Because it turns out that there is this predator prey thing that, when one goes too high, like the predator goes too high, it actually drives the prey down far enough that then the predators crash, which then allows the prey to rise up. So you have this thing that's this. Okay. So anyway, they introduced the wolves, which is seen as the bad thing. And as soon as they got elk under control, it turned out, then what they call the riparian corridors, which is the trees and the stuff along the stream, started to develop. And then when those started to develop, it brought back all kinds of other wildlife. And so reintroducing the wolves, which were seen as a negative thing, in the bigger system, at a really positive. And so a biologist would tell you that, it's never that simple, right? You got to always look at the higher stuff. But, having said that, then I don't know, what's that book, The Laws of Power? 48 Laws of Power. Anybody ever seen that? I could find the reference, but it's here somewhere. It's kind of depressing to read it for me, but if you read about it, you could be aware of how this stuff acts and how you might be able to work, if not to use it, to at least be less affected by it. So I think I've danced around your question, Luke, but I do agree that there's equivalent or more about quote unquote the negative effects of this coupling as well, right? When people just try and, like, money exchange works for people because they pick up a little, right? They pick up a little, which, do they really deserve it? I don't know. But anyway, every boundary transaction, right, is mediated by people who pick up a little, right? The middlemen to kind of do something. To a certain extent, you got to have them, you love them, but at a certain point, it becomes like the money lenders in the temple, if you know the Bible stories, right? It just becomes too much. So anyway, you can tell it's complicated and I don't have an easy answer, but it's a great observation.
Thank you. So next up we have Richard, and I guess Bill left. All right, go ahead, Richard.
Yeah, this is very interesting, and it may be the best place for me to put my experience with Precession on the table to find out whether or not I've been misusing it. Everything that's always said about Precession implies that the consequence is always unintended. In my work, in sort of human relation counseling kind of work, I turned that around and said that if you have a coupling of two people, using that as an example, someone who is a helper and somebody who is wanting or needing help, the axis of that relationship in a zigzag kind of movement can create a intended consequence. In other words, of being able to move from problem to solution. And so I have used precession. I've reinterpreted it to mean that it can also be the perpendicular sort of process coming out of the axis of the relationship of two or more people. So I guess I'd like to put it in front of the group in terms of whether or not that is a misinterpretation or a misuse of the original concept of precession being something that creates an unintended consequence.
So if you were looking at it as two vectors, it'd be the resultant vector. Am I hearing that right?
That's right.
Yes,
When you'd add
that's
the
correct.
two?
Yep. Mm-hmm. Yep.
And so that's part of the question is the action, reaction, resultant. Is the resultant always an unintended resultant, or can you in fact create or try to create a situation where it can be intended? And then what you have to watch for is the little trim tabs or the nonlinear sort of butterfly things that where a smile can produce a big satisfactory outcome, or a inadvertent roll of the eyes can turn somebody off to the point where they say, "You ruined my life as a counselor," because you seem to denigrate me at just the absolute wrong time in that meeting that we had. So anyway, I'd like to see what this group thinks about this, because I don't want to be using it incorrectly.
I think that's reasonable in that I know in the regenerative regenerative leadership book, they just call precession side effects. They use the word side effects and they say that is precession. So I think it's a useful thing, but I think that the fact that the physics description of precession, especially of a spinning object, that is predictable. So we can say that precession is predictable as opposed to synergy, which we cannot predict.
I think same as Richard, I must have missed it. I might have made it up in my own fantasies, but I used to tell our participants all the time when we tried to explain precession, what if we plan for precession? As an organization, is it part of our responsibility to plan for positive precession and also plan for unintended, what might then precess from that? So I always try to use it in a positive sense, but to always signal that we are responsible for the negative outcomes.
Yeah, so we actually do a nice progression from creating synergy, which you cannot predict, but you can hope for. And what we say is when something unexpected happens, we call it serendipity. And it's often because of synergy. It may not be, but it often is. So I'm saying, well, okay, if we do that through, and we do the 1 + 1 = 4, proving that synergy requires diversity. In other words, you need to have two different triangles, or triangles doing two different things, and interdependence. You have to work together. So if you have those two things, you can expect synergy. You can't predict it, but you can expect it. So when serendipity comes, take responsibility for it. But when you get adverse, that's positive precession. When you get negative precession, take responsibility for it. You have to be responsible for both positive and negative. but the potential for 1 + 1 = 4, in other words, twice as much synergy, twice as much productivity as you expect, that comes at a cost. You know, you're going to have to take responsibility for the benefits, but also for the negatives if they occur.
It seems to me that what we're talking about, especially with what Richard brought up, is it's really related to the environment that is provided and the context of that environment, and that's where the responsibility lies. Whether it is done well or done poorly, you take the responsibility of that, but it's based on the context of the environment and the relationships between the people in there, which to me, environment basically means everything outside the system and in the system. So
All
I
systems are
completely
nested.
agree with that. No, I completely agree with that. I actually, again, I want to come back to that as an example in a moment, but Jeannie and Richard had their hands up, unless somebody else has it.
Well, I wonder if I should just go back to Richard's first question.
Okay. Okay.
I just let it go because it seemed like other people were answering it. And so yes, it's perhaps unfortunate that Bucky used unintentional, right? Because as you've all pointed out, you know, many times, especially in socialist systems, we do intentionally do things. And I think his intent on saying unintentional was to make us aware of it, right? And it's a possibility for positives as well as others have pointed out, possibilities for negatives. And I actually had a student, I know a couple years ago, I lectured to MCAT about Bucky and talked about precession. And his question was, well, how do you design for precession, right? So there's a whole nother book, right? And the best example I could get was I used to go to a thing kind of like a physical meetup, and you put on a name tag and say, my name is Curt, ask me about, and it'd be something that I, knew at the time, probably biomimicry or Bucky. And then the other thing would be say, I want or I need. And so the idea was you would sort of display these things, right? That it might take a while for somebody else to figure out that you knew about or that you wanted, and you would force these sort of new connect stuff. So I don't think you're using it wrong at all, Richard. I think it's a great example, and it's a reminder to me to just make sure I frame this, I talk about it, to talk about that you can design for it, that there's things as, and like previously, there's also the positive and negative skew. Oh, and Joseph paused. So Luke, yeah, I didn't even get into the thing, which is that Bucky's use the word precession is not the, precise physics way, right? But he does go into the physics way to demonstrate to people that he really knows what he's talking about, like the spinning gyrograph, and he's got the guy twirling the shot put, right, and examples in it. And so he's expanded the idea, and you can see how he's done it, right? Because in the physics examples, there's this interaction of forces, producing this other thing. So he made a good leap, I guess. But yes, if you were talking to an absolute scientist, he would probably push back a little bit on it. So thanks for posting that stuff. So, okay, back.
So we'll go to Jeannie. Richard, actually, do you want to comment in response to that or not?
No, we can go to Jeannie and I'll come back. I want to talk about the synergy part too.
Well, I wanted to bring up the idea of experience. So once you have experience with a situation, you can begin to understand the precessional effects more easily. For instance, I sometimes ride my bicycle and the handlebars are, way out of whack. And I just I can ride my bike like that for weeks. And, you really need to just push a little harder on one side so you can compensate. I think the problem really is that in the way we think and plan, we just try to look ahead and go in one direction, and we don't think verbally, about the things that are going to happen on the sides. So I think it's in many ways a language thing that we need to begin to get into the language the idea of precession.
Yeah, I was actually going to ask you about that, your example with the bike, Curt, if you could actually expand on that a little bit, as to why you use that, because I thought that that was actually pretty interesting and how to possibly explain precession and then specifically within within a system and symmetry actually as well. Do you have any comments on that?
Well, the bike slide is there because I'd used it previously as an example for people to see systems everywhere. And but you're absolutely correct, right? That there's, guess what? You get riding a bike and you have that rotating wheel, don't you? Right. And then you learn intuitively what to do about it, right? And in terms of the leaning and the steering and what Jeannie's talking about, right? So you, once again, guess what? These coupled systems, totally that. But then, side effects, the picture of the sort of three-wheel bike being used in some sort of public market, probably in China, you start to look at, oh my gosh, these sort of things as a quote unquote side effect, it didn't just get a person from point A to point B. I mean, back in the day, I think my wife's grandfather was able to meet grandmother because he borrowed a bike and he could get between these towns. There were no cars then, right? There was no direct train, so, and he didn't have a horse, right? So anyway, there's these processional effects to things like that as well. And then the fact that you can carry all the stuff on a bike, by getting between different places on a bike, you learn more people. So yeah, once you start to think about the bicycle and the sort of metaphysical effects, if you will, of its use and the behavior, and especially the processional one, I think is very.
I think we lost you at the last second there, but Jeannie, did you want to follow up or Richard?
Well, in terms of those kinds of examples, I also use the example of the traverse in skiing, the tacking in sailing, the fishtail or the fish getting from one side of the fishbowl to the other, and so what you have is that action reaction resultant that actually moves something perpendicular to the axis of the fishtail or the traverse. And the parallel for me in the helping relationship is the perpendicular is like the fall line, and the helper and the helpee, if you want, have to crisscross or fishtail back and forth in order to create the motion that's desired. If you just get out in front and pull someone towards the solution or behind them and push it, it won't work. And one of the better zigzags for me in terms of just creating the image of what you can do with it is trying to move a heavy object like a fridge across the kitchen floor. If you try and push it or pull it, you probably can't do it. But if you can get it zigzagging a little bit, you can twist and turn it and it will move across. And that to me is the whole concept of precession in the sense of the perpendicular or the axis and the perpendicular motion. Now, synergy for me in the same context is when you get two or more people coming together to do something that neither one of them can achieve on their own. So the person that's a helper can't become a good helper unless they've got somebody they can help. And somebody who needs help can't get that help unless there's a helper. So at the end of the day, at the resultant, you end up having, if you want a client saying, thank you very much, I really got a lot out of that. And you have a helper basically being able to say, if it hadn't been for you, I wouldn't have been able to do what I've always wanted to do. So it's a win-win, as you've talked about before. And it really makes some sense in terms of how human beings get together in order to create a motion in a certain kind of direction. And the precession, I think, is a beautiful example of that. We could also go further if we wanted in terms of the 6 motions. You've talked about orbiting, but there's the expansion and contraction. And I've always been limited in using those 6 motions to just trying to use precession. And then when I got into trying to use all the other 5 or 6, it's amazing how much they add to one's understanding of the kind of motion or the effect that you're trying to get going between 2 or more people, whether it's in a conversation or in some other kind of purposeful sort of action. So it's been exciting for me to try and put precession and synergy and now some of the other movements together, motions together, in terms of understanding the human dynamic of working back and forth in a zigzag kind of way in order to create a motion that's perpendicular to that axis. So again,
Wow.
with this kind of group, it's refreshing to be able to put those ideas on the table and have people sort of say, "Hey, I like this," or "I don't like it," or "I think you've gone down the wrong road." I've never been able to have this kind of audience to be able to have that kind of dialogue.
So maybe actually, could we like break down the 6 with spin, orbit, inside and outside? I think we kind of have already to a certain extent, but you know, expansion, contraction, torque, and precession from there, right? And break down each one of those and see how they fit together.
Well,
I can
provide some kind of examples.
Well, I can bring that slide back up, but I think this is almost another meetup, right? Another topic. Get Richard to present on this. Luke had his hand up for a minute, but I don't know. Did it get covered, Luke? I could bring that slide up though. Looks like he's okay.
What I back channeled with Richard. Basically, I was going to ask about the 6 motions, and then Joseph brought it up, so he brought up my question. So we're there.
One of the things that I found to be like one of the more interesting things is this idea of how, you know, Bill was talking about the idea of contracts and how that works and how there are mutual agreements, but we'll come back to that in a minute.
Okay, so this is the text from Synergetics, and I had it in here and just I emphasized orbiting because, you know, the complexity of orbiting, right? Especially with the idea that you're sometimes a shared electron going around your organization, sometimes going around your partner, I thought was a really nice one. Turns out even in quantum theory, sort of the same thing happens. It's just that it's a much fuzzier cloud, it turns out. But this has the other ones. And so I'll just say spin, you know, if you imagine yourself, you know, as this metaphysical tetrahedron or polyhedra, I should say, like that picture. Well, of course, none of us is perfectly symmetrical. We're all continually subject to forces, right? So we have social forces, transactional forces, you know, seasonal forces. The result is we all spin. So everything, everybody is continually spinning. So I'll leave it at that. And I've talked about orbiting, and I'll defer to Richard on anything else.
Well, I mean, just one example is expanding and contracting. And I found out, again, when 2 people are working together, sometimes if you get in too close, then that's can be a problematic type of relationship. If you're too far back, then you're too distant. So you actually have to get the right kind of expanding contracting. And the same thing with sort of orbiting. Orbiting was a concept that I was able to use to say that, you know, you can help someone get going on their own orbit, but you can also set it up in such a way that if they want to orbit back through your sort of pathway or orbit, that's a possibility too. And so it creates that idea that once you've gone through a particular kind of experience with someone, it doesn't mean that it's the end. You could actually orbit around and come back through that relationship. So I've just been experimenting with the 7. I have some graphics that try and outline how it might be used in a human relation type of way. So it's just kind of this is what these readings, these discussions, a deeper exploration of Fuller's work has done for me. At least it's got me into things that I didn't think I was going to either need to or realize how many things I'd missed in the first read or two of whatever books I've been accessing around Fuller's work for many years. So I love it anyway. It's stimulating and innovating.
Thank you, Richard. Curt, do you have any comments on that?
Those are great examples, Richard. And like I said, I think this is a whole different presentation. And maybe it's for 52 Living Ideas, or maybe the Trim Tab Book Group. And maybe there's even one presentation for each, right? For each of the motions, because I don't think any of us have really explored the depth of them. Like torquing. What does that mean, right? And yeah, so I think there's a ton of stuff there, and I really liked your explanations, and that expanding contracting fit right in, right, with what Bill was observing about what we're saying about right systems. You change, but the other system has to change, right? And then you change, and so then systems interconnection, like Bucky said, is how the whole darn thing works, right? And that expanding contracting is a nice metaphor for that.
Yeah, torquing for me was a way of being able to say, oh, that helps me understand when I need to sort of zero in, focus in, sort of tighten the screw, so to speak, to make sure I'm really paying attention. It's like what you put forward earlier about thought, and making sure that when I've got a particular thought or an important thought that I want to share with somebody, I get rid of all the other irrelevancies around it so that I can really concentrate on getting that thought, if you want, out or across to the point of somebody else can experience it or understand it.
There's a hand raising.
I had a request for clarity, shall we say. With these 6 motions, we're talking about coupled systems. Am I wrong when we're talking about this? It'd have to be 2. Okay, just making sure.
Yes.
Because I've studied motion a lot, and this is new. Thanks.
I think John and Yoshimi, you have a comment, or we're looking to raise your hand.
I was just thinking, we're working a lot with spirals right now. And to me, the way we're using spirals, it's sort of like an orbit that lets go. You got to let go. So you may be orbiting. And a lot of the things that we're learning about and supporting people, including ourselves, to do is let go. So it's just a visual for me. It just made sense to talk about orbiting and then talk about letting go and then go into a spiral.
We have the saying, which we could call a Yodimi quote, is to let come, let go.
It's a lot of letting go that.
So if you let go, you'll receive from the universe.
Anyway, it's what we play with.
Are there any other comments or questions for Curt?
Well, it's been wonderful. It's always useful just to put it together, but especially the way you've been doing it lately, where we pause, because you folks are really engaging with the material, and so it's very, very useful. So I want to just thank everybody for that.
Oh, Julie actually has her hand up.
Yeah, I'm new to this, but it seems to me that if by learning this material, you would suddenly go back out in the world and see these principles operating in all kinds of life relationships. Is that true?
Yeah, I mean, none of us to the level of which
And
yes.
you would gain understanding about some things that you didn't have prior, and you might even add understanding by taking something and testing it, putting it to the test.
Yes,
so
exactly.
It seems valuable.
Well, thank you.
Yeah, let me give you one example. With this idea that Fuller had of, if you know the number of nodes, you can figure out the number of relationships in between them, or the minimum number. And I created a contextual model that has to do with who you are as a person, how many parts you might see in yourself, like your physical, emotional, spiritual, etc. The values that drive you, the people that are close to you in your relationships, and those societal institutions that you have to deal with on a day-to-day, whether it's the transportation system, the education system, the health system, etc. And so I asked this particular person, I said, let's add them up. How many parts do you count within yourself that's important? Again, physical, mental, etc. And so we had, say, 4 parts, and then how many sort of values or beliefs or norms that are important for you, and named another 5 or 6, and how many people are in your sort of close family relationships, friends, and how many institutional systems are you dealing with on a given day. And so when we added up the numbers, and you can get quite a few, let's say even just 25, and then you multiply 25 by 25, you square it, then you subtract that number, 25, and you divide it by 2, and you get the number of relationships minimum, just one way, basically. And so when we added up all these numbers and did the little formula calculation, and showed this person how many relationships she was really dealing with on a day-to-day basis. Some of them were automatic. It's just, you just do them. Some of them were conscious and you had to pay attention to them. But the number that I gave her created an instant reaction. And she said, oh my God, no wonder I wake up in the morning with a headache. But the beauty of it is that she realized that she was handling all kinds of relationships. Maybe 1 or 2 weren't going as well as she would like them to be, but she ended up really saying, I have a right to that headache. Life is complex. And so it's a real eye-opener for any one of us to count up all the things that we are dealing with on a day-to-day basis, and use this little relationship kind of formula that Curt was sort of alluding to or connecting to. And it's amazing what kind of clarity it can give to us in terms of what we're trying to cope with and deal with on a given day-to-day basis.
So there is one thing if I could ask, just for a point of clarification, when I hear about Bucky talking about, again, the idea of leaky corners and things along those lines, how does that differ from, say, within a graph, where you have a connection between the nodes and you have edges that are essentially connecting the nodes. And then you have directed and undirected graphs. Is there an analogy similar between what Bucky has, is talking about with leaky corners and essentially graph theory?
Well, sure. I mean, what Richard described, could be a graph. And a graph in this case, if you haven't figured out,
Right.
is I'm going to show all the points and all the ways to connect the points, right? There's other uses of the word graph, like a way to illustrate the change in something over time, but this particular form. And there's an enormous amount of mathematics on graphs, right? They're used everywhere in all kinds of things in search and optimization and, everything. So what Bucky would say about any given graph, if you or somebody said, oh, this is the graph of this thing, he would say, well, is it closed in 3 space, right? So it's got a bunch of nodes, a bunch of interconnections, but does it actually come together? So if it hasn't, you haven't really captured a system. You've captured some aspects of it. Maybe they're the most important ones, but until you actually add enough points that it closes itself up, that's the first thing you'd say. And the second thing he'd say is, well, okay, you drew all those points and you said that was it, but I'll tell you that every one of those nodes actually goes out to some other system, right? And so you may want to go look at it and be aware of it. So graph theory is very powerful, but Bucky would say, just remember the graph must close, if you will, right? If you put it together, it becomes some super complicated shape, but it closes it together. It's not a flat thing. It's like, oh, there's a part over here and a part over there joined by a single line. No, that's not a single system. It might be 2 systems. That's the first thing you'd say. And the second thing is, okay, well, on that graph, you said this is the most important stuff, but what about that wolf? You said it's only how the wolf relates to this, that, the next thing. Maybe there's something else about the wolf. He would say that's the leaky corner that you might want to think about. Anyway, that's one view of it.
Okay. Thank you for that. Yeah, I always wondered a little bit about that connection.
Yeah. Well, once again, thanks everybody. It's always wonderful to do this stuff and to see everybody and have such a great crew and great questions. Very valuable. So really appreciate it.
Well, thank you. We appreciate you, Curt. Every month coming by and actually, doing this with us and being so gracious with your time. It is something. It's one of the meetups that a lot of us look forward to each month here at 52 Living Ideas, and we're, sincerely appreciative of your willingness to continue to do this. This is it means a lot. So, and it adds a lot to our meetup in particular. So we have some just some quick announcements for this upcoming week. We'll have a poetry meetup on Monday, and that will be at 8 p.m. And then we'll be covering Confucius, the Analects, and we're on book 14 for that. And that'll be on Tuesday. And Wednesday, we'll have our Neuroscience Wednesday, which is actually done in conjunction with the Greater Philadelphia Thinking Society, like this meetup, which both were inspired by CJ. And then on Thursday, it remains undecided, I think, for this week. Or is it, Ebony, do you have an answer for that? Are you on any?
Yes, it will be Brian will be doing a session on Joseph Campbell. It will be a series that is it's the first and third Thursdays of the month where we view a video about Joseph Campbell, and he talks about myths, and then we have a discussion. So Brian Nelson leads that. It will be every other Thursday from 8 to 10 p.m. So that's what's happening this Thursday.
Fantastic. And then on Saturday, we'll be covering Louis Sullivan. And I was not there yesterday, but hope to be there this weekend, who is another architect and a deep thinker as well. So thank you, everyone. It's been wonderful. It's a privilege always to spend time with everyone here. Again, Curt, John, Yoshimi, Richard, very much appreciate your time. Paul, Katie, Brian, everybody that was here. And so we will see everybody soon, I hope. Good night.